right? Perfect, perfect, perfect from all directions. Now, yeah, the coil is good. So let's change the direction again. Sorry, the orientation. Let's make that top view. Let's see how it looks when we bring in another one. Okay, oops. So let's just delete this, select this one, mirror it again. Sorry, before mirroring I must copy it. I must copy this, paste this. There's this mirror, right? I'll mirror this, go in, click just one grid away, successfully mirrored. And I'm looking at this now. Yeah, this looks good. Sadly, there is just 2 number of turn, but I think we can work it pretty fine. Okay. Now, if you want more number of turns, what we can do is reduce the polygon, the dia, right, or the radius, and then reduce the pitch as well. The pitch means this gap, right, between the coils, between the number of turns. So without wasting time, let's see what we can do. First thing, changing the name of this into coil. The second thing, changing it into copper material. Now we have, oops, the 2 core material are not copper. Sadly, I mistook it. It's ferrite, right? Yeah. So these 2 are ferrite materials. I have assigned that successfully. Now this is copper material. And still we're a little bit far from achieving what we want for today. So changing back to top view. Now, here we need to take care of a few things. First, we'll select all of them, set the transparency of all of them to opaque, right? Let's change the color of this so that we can see it clearly to something that looks like copper. Maybe this, right? Yeah. Okay. Oops. So here, what we need to do is we need to assign region as well, right? So region is air medium, right? So for that, we can create a cuboid first, right? Now we can create a cuboid like this right over here. So this is the region. I will click it once, then I will press the tab, and for what I know, maybe it is 5 mm, not more than that. So let's see how it behaves from front view. Oops, 5 mm is quite huge because the scale is small. So let's reduce that to 2. Perfect. But still, the alignment is not there. This object must be in the center. So I need to move this vacuum box. From create box, I will change the position to -1. That will bring it to center. Perfect, right? Yet not so perfect. It is in the center, but one thing that we need to satisfy is the boundary condition, sadly, right? And the boundary condition, as we know till today, from what we have done to satisfy this boundary condition, the extension for the excitation that we'll do in the next section, right? If I excite it right here, which is somewhere in the middle, and it is not touching the boundary, right? So boundary surfaces need to be touched upon to successfully complete the boundary condition. Now for that, we need to bring in the extensions. So let's draw the extensions first. So right now, I will just hide this, zoom in a little bit. So there's that face, press F in the keyboard, or just go here, right over here, and select face. You can do anything. So E, edge, F for face, O for object, right? So face is what I want right now. I'll select this face. This is what I want, right? So I would draw an extension right from here towards the boundary. Similarly, I'll just turn it around. And for this face again, this is the second face, right? I will draw another extension that I will excite, right? So let's come back to this one. So let's just start to draw the extension. Now we know how to draw that. We'll just press the line segment, hover around, detect the center, bring in one line segment, double click it, Now after clicking here, right, it will create a line segment, create line. So this is the line. The center is okay, right? That means the first point is definitely fine. What we would want is to copy and paste in the second point, right? And do some few changes. Now if you see the scale right over here, this extension should be in the Z direction and in the positive Z direction as this coordinate suggests, right? So I would like to add Z direction, and that would be positive Z direction, maybe 2 mm, right? Oops. I didn't think that's right. So what mistake did we do right over here? Or is it correct? I think that's correct. Or my eyes are just hallucinating right now. I'm not sure. Let's see. Zoom out a little bit. I think that's how it should be. Yeah. It should be perpendicular from that line segment or that face. Correct. So yeah, looks fine. So let's see. Now I need to change this polyline from line segment to a circle cross section, right? Circular cross section. But when I click there, it asks for diameter, and diameter would be equal to the diameter of this polyline segment that we drew in the coil, right? So just to confirm, go back to the coil that we drew here and check the polygon radius. So it's 0.03125, right? Now just double that, it will be the radius that we would want, right? So it's 0.0625. Now come back to the polyline, enter the diameter 0.0625, and this is what I want, right? The bending type is corner, it's fine, okay, right? So this is what I want. The extension, isometric, fit all, perfect, right? There's an extension. Now after that, let's come back to this one right over here. Let's see what can be done about this. The same process is to be repeated for this, right? Draw line segment, hover around, straight draw, double click, done. There's this line segment, this is it, double click, first point is okay, copy paste. Now check which direction is this. I guess again this is negative Z direction from what I understand, and 2 mm again, supply, okay. Now my eyes are kind of deceiving, but it's fine. Polyline, circle, change the diameter 0.0625, perfect. Let's see. Isometric view, fit all. 2 extensions in 2 direction, right? So successfully created. Now this line segment or these extensions must intersect our region. Actually they must kind of outgrow in size. They must be larger than the region itself, because we want certain other operation to carry out there. So if you remember from our last video, whatever we did, so that is what exactly I'm using here, right? So I will draw box, subtract it, and then just cut it into a very nice plane which will just intersect the boundary. So to make it just intersect the boundary, we need to subtract the cuboids, right? So this is our box. Let's see if it intersects. Perfectly intersects, comes out of the box. This is exactly what I want, right? So good to go again. So I will select the box, sorry, not the box, but the polylines, right, along with the coil. So select the coil first, then polyline 1, then polyline 2, and first do the Boolean union here. Unite it. Now this is a part of coil. You can see the material is assigned as copper, and this is a perfect coil extension, right? Now we have this box which is supposed to be our region. Now I would name that as region, right? And the region would be air medium. Here's the air, so this is air medium. Now the assignment is correct, the region with air as medium. Now in this region there's one extension, right, that's coming out of it. First, let's just change the transparency again, make it opaque so that it will be easier for us. Now what we'll do is, this must be exactly equal to the region, right, the boundary. Now for that I will see which plane we are working on. So I will need to work on this section, this face right over here. I guess this is XY plane and our grid is in XY, so perfect to go. I will select cuboid here, just detect the corner, draw the rectangle and cover the whole extension by coming in this direction. Perfect. The coverage is there. Yeah. Similarly on the next direction, again same plane, so no worries. Provide the cuboid, draw the cuboid, bring the extension, oops, and it is covering it, right? Perfect. Now what we'll do is we'll do Boolean subtraction. So this is box 1 right over there, this is box 2, both of them are covering the extension. Now we need to subtract that coil from the box, right? So let's do the operation. Coil. First select the coil, then press the control, select box 1, select box 2, do the Boolean subtraction. So coil minus box 1 and box 2. Done. So as you can see, this is the perfect intersection in the boundary for the surface of the coil. This is perfect intersection, right? So this is what exactly we want. Now let's come back, press O and the object, reduce the transparency, increase the transparency, and we are good to go. I can see everything is set fine now, right? Now select this, hide it, zoom in, select, press button F, select the face, right click that, assign excitation, assign current. Now name it coil in. Now the excitation would be somewhere around 5 amps. This doesn't make any change in magnetostatic, static, right? No worries in it. So the excitation is made. Let's just check in. Yeah, it's correct. So you can see the arrowhead, it's going in. So the next point would be out. So select that face, assign excitation, current excitation. We'll name that as coil out. The value would be 5 amps because it must be same. But right now here we need to swipe direction to make it outwards, right? I guess it's coil in, correct, coil out, correct, right? The materials are already assigned. The region is already created. There's coil, there are 2 cores, right? Perfect. Isometric, fit all, view all, and we are good to go. This is it. That's our object. Everything is ready, right? Now the next thing is parameters. Right click, assign matrix. You can see coil in, that's the conduction path highlighted over there, correct. Now the next is mesh operation. Now few things to take care again. Select e-cores, right click, assign mesh operation, not on selection, not inside selection but on selection. Length based. Now this is core, so I will just type in core. Whatever default value is there, that's a detection from the computer side, from the Ansys electromagnetic desktop, right? So let's just skip that one for now. Okay, right? So no issues with that. You can change that or even limit the mesh size. But right now, let's just stick to default, right? So for coil, again, right click, excitation. Not excitation, mesh operation, inside selection. On selection, length based. Now this is for coil. 0.4, okay. The last one is region. it's a little bit different, not on selection but inside selection, length based. Now this is region, right? Default value, whatever there is. Now comes analysis. Right click, add solution setup, percentage error, that's fine. Convergence, minimum number of pass 5 at least. Solver, everything looks good. No need to do the iterative solver, right? Because the dimensions are very small, so that's fine. Analysis is created. Now it's the turn of the results. Before we plot results, let's just finish the analysis first. So do not forget to save whatever progress we have made till now. It will take some time. My PC is really slow. Okay. Now, simulation, validate, everything looks good. Now, just go to the setup or the analysis, right click and do analyze all, or right click on setup and do analyze, right? Let's wait. Okay, that looks great. Normal completion of simulation solver. So we have the output, the analysis is done. So let's jump into results first. Right click, create magnetostatic report, data table, and select the matrix, select the L value of the coil in report, right? So this was a small, so it is coming around nanohenries, that is 500 nanohenries almost, right? Now, yeah, so let's estimate, right? The output is so fine, and what we can expect from such a small core, right? With just 2 number of turns. That's perfectly fine. Now let's just see the view values over here. Select the object, hide the region. We're interested more on the core side. So I guess top view will be better, right? So yeah, let's select the faces. This face and this face, right? This is better. Let's see how the distribution works. So right click, field, B field. Now Mac B, all objects done, right? So yeah, kind of good. Or maybe we can do better than that. So go to B, right click, modify attribute, change the scale to logarithmic. Now that looks somehow much better, right? So the scale is still same, just the scale value is changed from linear to logarithmic, right? So in log scale, it's more viewable, the gradients are more viewable, right? Now, one more thing, what we can do is, again, select the E-cores or the whole core, right? This time, go to fields, B field, B vector, select all object. Let's plot on surface only, right? Done. So that will allow me to see the vector, right? So this is how it looks, the vector, right? I guess we are done with this. Nice. Much more viewable. Let's just turn off the grid so that we can see this clearly. Perfect. The alignment is good. This is how it should have worked in real, and it is working fine, right? We can change the direction. We can see how the intensity changes. I mean the line of flux changes, right? When we do switch the coil in and coil out, right? So that you can see. Further, what you can do is you can plot the H field as well. Again, select the E core, coil, right click, field, H field, maybe vector, right? So this will be better. Plot on surface only, done. So this is H field, the intensity. Okay, it will be much better if we'll turn off these two. Just hide this one, hide this one. Now this is just the H value and looks much better, right? So yeah, this is how it's done. We have the L value, in the table, and we have the B plots, right, respective plots right over here. So this is B vector, this is Mac, and this is H vector, right? So I hope you can now do this on your own. Once you're used to this, we can kind of level up things, right? So that's all for today. Before stepping into more complicated forms and going towards the transformer, I hope you learn this by heart, like all the steps, do this repeatedly, right? I hope you've learned new thing today. Thank you so much. Goodbye till next video.